This week, Philippe Lafoucrière, Distinguished Security Engineer at GitLab, will talk to us about transparency in large supply chains. Then John Smith, Principal Engineer of Security at ExtraHop, joins us to discuss putting the R back in NDR. Finally, in the enterprise security news, inertia in cybersecurity strategy. Check Point acquires Avanan. Absolute Data Explorer. BreachQuest launches with a $4.4 million seed funding, acronym bingo, and so much more on this episode of Enterprise Security Weekly. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where we talk security vendors and aren't afraid to name names. It's Enterprise Security Weekly. Every 11 seconds, there's a new ransomware attack. Oil pipelines, universities, corporations, all paying millions of dollars. Barracuda says, don't pay the ransom. Before a ransomware attack occurs, train your teams to recognize an attack and use anti-phishing technology. Protect your applications, and they can't get onto your network. Simple backup and restore solutions quickly recover your data without paying the ransom. Build your ransomware protection plan now by visiting securityweekly.com/Barracuda. That's securityweekly.com/Barracuda. Did you know that 81% of data breaches are caused by weak password security? Keeper Security's easy-to-use password manager platform keeps your passwords safe, easy to share, and out of reach of cybercriminals. Keeper is the leading cybersecurity platform for preventing password-related data breaches and cyber threats. Check out Keeper and get a free 3-year Keeper Password Manager solution when you take a demo of Keeper for Business. Learn more at securityweekly.com/Keeper Security. Whether your biggest cybersecurity concern is ransomware, unprotected network devices, zero trust success, or auditing your supply chains, firmware security is critical. Eclipsium's enterprise firmware security platform helps you identify devices and their firmware, verify the integrity of firmware wherever it's used, and fortify firmware through active remediation and automated patching. Visit securityweekly.com/Eclipsium to try out Eclipsium or learn more about enterprise firmware security. Welcome, everyone, to episode number 241 of Enterprise Security Weekly, being recorded on September 1st, 2021. I'm, of course, your host, Paul Asadorian, joined remotely by my first co-host, Mr. Adrian Sanabria. Adrian, welcome.
Hey, how you doing, Paul?
I'm realizing how hard writing is when you haven't done it in a while. Adrian's like, fill out this template for the labs report. I'm like, oh, man, I got to, write stuff. I'm like, this is hard. Can I go back to the lab and play around with Linux and security products?
Man, it's a different part of your brain. It's
it is.
Yeah, it takes a few kicks to get the engine to turn over.
Yeah, I got it done though, and it's in the editing process. You should be seeing some reviews for vulnerability management, both open source and commercial products. Hopefully being posted today. Will some of it make it out today?
Yeah. Yeah, maybe.
Maybe. If not, definitely tomorrow.
We're still smoothing out that process.
That's right. Mr. Lee Neely is here with us. Lee, welcome. Oh, I can't hear you, Lee. I don't know if you're muted on our end or your end. Oh,
there we go. How about that? That's much better.
What's up, Lee?
I had some noise in the background and had to hit that button. The writing, you remind me, I was, for the first time in a long time, writing up a risk assessment yesterday. Man,
yeah.
It looks easier on TV.
Right.
Yeah. I don't envy you. What we're writing up is much more fun than that.
Yes. And on Paul's Security Weekly, you'll hear some corrections as well. I actually got in touch with the folks over at Greenbone, and they were really super nice. They saw our segment on Paul's Security Weekly, and kind of set the record straight on a few things that I kind of had glossed over. So it's pretty awesome. All that's in the report, and hopefully there's a webcast coming up on open source vulnerability management as well. So I'm going to tease that out there for everyone. Alrighty. I have announcements to read, don't I? InfoSec World 2021 is proud to announce its keynote lineup for this year's in-person event. Hear from Robert Herjavec, plus heads of security at the NFL, TikTok, U.S. Department of Homeland Security, Stanford University, and more. Plus, Security Weekly listeners save 20% on a World Pass and main conference registration by visiting securityweekly.com/ISW 2021. This segment is sponsored by GitLab. For folks that want to learn more, please visit securityweekly.com/GitLab. Philippe is a distinguished security engineer at GitLab. He's joining us today to discuss adapting to a world where everyone can contribute to maturing security posture faster than attackers and transparency in large supply chains. Philippe, welcome to the show.
Thanks for having me. Super excited to be here today.
Nice to have you, Philippe. How did you get your start in information security?
Actually, that was a while ago. We were doing a lot of contracts, and when we started Gymnasium, that was the company that I started, and I was the CEO and founder of that company, which was acquired by GitLab. We discovered that it was extremely hard for us to track all the advisories that went out mostly every week. And we had a lot of trouble identifying the versions of the software that we were using in all the projects that were shipping to production. So that's where the idea of creating something to track dependencies and managing these dependencies came out. And we did that actually for a long time, for almost 10 years before getting acquired by GitLab. And I've been working at GitLab for almost 4 years now after this acquisition.
That's awesome. Philippe, do you feel like developers rely more on inheriting software and libraries and modules than we did in the past? Because of course we always had this concept, even way back in the days of C or even before that, right?
More than ever, actually, because there's the chance to have something that is already done or really available on the shelf is higher than ever before.
Yeah.
Yeah.
Do you remember the first? I discovered the first occurrence of this, Philippe, and you'll appreciate this being in this kind of vertical at MIT when the programmers were on punch cards creating some of the first code that was running on some of the mainframe and large computers that were in the university at the time. If they wrote something what they thought was really good, they'd put it in a particular drawer, and then any other programmer could go to the drawer and retrieve those punch cards. It's a lot more advanced today, I guess.
Good old times, because you could trust what you found in the drawer. That's not the case anymore,
right?
Unfortunately.
Yeah, and there's a lot of interesting aspects to the SBOM as we call it, but also what is the acronym? What is the vertical that we call this? The acronym always escapes me. SCA, right?
Yeah.
Software composition analysis.
Composition analysis. I had a mental blank there. Sorry about that. And having done some development myself, some of my first questions are like, how deep does the rabbit hole go? Like with transient dependencies and dependencies of dependencies. Philippe, how do you handle that problem? Because you could go into an infinite loop essentially.
Yeah, pretty much. That's a great question. And especially at GitLab, where we have pretty much thousands of projects now, it's really hard for us to figure out exactly what we are using. So we are working really hard on building this SBOM that you are referring to, the software bill of material. So it's a kind of inventory of everything that we are using in the process of creating or shipping or packaging GitLab at some point. And always remember that GitLab is also a huge part of the supply chain for a lot of our customers. So we need to make sure that our supply chain is very secure. So this rabbit hole that you're referring to, it's never ending. Actually, it could go down to the hardware. How much trust do you put in the hardware that you are using just to compile something? How much trust do you put in the compiler that you are using? Everything should be green from a security perspective when it comes to reading the code and reviewing all the changes. But if you are using tools that are not safe, you are introducing something that will go along with everything that we're going to ship later on.
Yeah, it's a great point, Philippe. I sometimes, when you say that, I'm like, yeah, the build process is something you have to trust as well. And I was just compiling software, and I was using CMake that creates the make files, right? So that you can actually build the process. And I'm like, that's really like a build process that's creating your build process, but very much in the line of trust. And I think we always think of that line of trust as what libraries or modules I'm importing. But you're right, it extends to really everything that is in the production of software.
Yeah, we never take for granted that something is going to be completely secured. So that's why we have different phases in the production of GitLab where security is kind of very important. We have 2 stages, for example, that are completely dedicated to security at GitLab. We have the secure stage and the protect stage. Secure could be seen as everything prior to going to production. So you prevent security issues from going into your software. But we know that's never going to be enough. There's no ideal solution that will catch everything. So that's why you also have protect. We have everything after you push your software to production. And especially something that I really, really like, it's something that we call live monitoring. There are solutions out there like Falco, for example, that are able to just monitor the behavior of your application when it's live. And it's going to catch everything that is unusual. The behavior of your application should be well known, and everything beyond that, that's your safety net. That's your catch-all net where you could get notified if something goes wrong, like you have a connection to a remote server that you don't know. That's very suspicious. That should be a red flag instantly. You should investigate on that. So that's why we like to combine different techniques in securing GitLab. It's not only running tools or reviewing code, it's also making sure that our production environment is always safe and we can spot anything that is suspicious to investigate right away. It's not a week later or a month later that we want to investigate. It's right away before there's any damage.
And that's where I like to rely on tools, Philippe. When I'm importing a module into or a library into my project, I have certain assumptions that I think tools are really the right way to discover if a module is accessing a file or writing a file that I haven't told it or I haven't given that library. Because like inherently when you're importing something, it doesn't know what files I'm working with in my application. And of course, there's going to be exceptions to that, right? But I feel like that's something you can trigger on. In addition to if inside the code for that module, it's making connections out to the internet that I didn't tell it to do, that should be suspect, right? And I think you've built some of this intelligence that can tell me, a developer or a security person, when these kind of events happen, right? And they're identifiable.
Yes, absolutely. That's also why we have different projects at GitLab that we are currently working on to just mature our security posture, especially when it comes to the supply chain. There is something that we just released to the public that is called Package Hunter. And that's a very interesting concept where it's dependent of live monitoring, but for dependencies. I mean, when we install dependencies in the production process, in the packaging process, we monitor the behavior of all these dependencies. And if there's anything suspicious in this installation, like, for example, there's one of the components, as you said, that is trying to access a file that is not supposed to access, then it's going to trigger a red flag and we can stop the build instantly. We don't even push that to production. We obviously want to investigate that before putting that to production.
And you're using, you mentioned Falco before. You're using Falco as part of that, right?
Yeah, Falco is the tool underneath that. Exactly.
What do you think the false...
the idea is...
I was just going to ask, Philippe, what do you think the false positive rate is on some of the, like, monitoring some of those modules? Like, do you have a sense from your users and all the things that you're monitoring? Like, what's the instance of false positive where you thought a module was doing something it shouldn't, but really that's a legitimate function, if it were?
It's very high when we get started because obviously you don't know exactly how your dependencies are going to act. But with time, you will get better at filtering what is normal from what is suspicious. The hardest thing to figure out is when you have something going out to a very large network like AWS. You don't know exactly what's going on there, and you have to go deep down in the code to understand exactly why you have this connection to something at AWS. It could be legitimate, it could be just some data that is gathering, for some metrics or something like that. But you never know, and you have to investigate, and that's the really hard and tedious part of managing the behavior of components in our supply chain.
So, I remember back when I was trying to do some a long time ago when I was building packages, and I was more concerned that I checked out the right version and I had all the dependencies, and it was really easy to not even think about security because the other part was difficult enough. Mm-hmm. And I'm thinking, it's great you're adding, layered products to help with it, but do you have anything somebody could use to say, hey, don't forget, you've got to do these, you still got these non-AI, if you forgive the term, functions you should be looking at, or when you see this kind of thing, really you need to do this, because I'm sure not everybody is astute about what needs to be done when you see a warning like you produce.
But I would say there is no magic recipe when it comes to dependencies. It really depends on the size of your company and the maturity of your company when it comes to how you are able to deal with this amount of data. Because if you start using tools for dependencies, the more dependencies you have, the more data you will have, and that could float completely an AppSec team if you're not careful. That's one of the problems that we had at GitLab at some point. We started to enable the tools on every single project, on everything that we could, and that generated a lot of data, and we were not able to handle that. So we decided to start from scratch, and enable the tools one by one to make sure that we were in control of the generated amount of data. But the main problem with that is not only we are using dependencies at GitLab, but we are also one of the most transparent company in the world. And that means we have a lot of people being able to contribute to our code. So we have a lot of community contributions coming to the product, and we have to review them, because the trust that we can put in a dependency is not the same trust as we can put in something that will legitimately be in our product when you ship that. So we have, again, different layers of process, make sure that all the components that we're using are completely safe.
And when you say you have a culture of transparency, you're not joking. Like I remember, I'm sure you guys are tired of people bringing up this story by now, but GitLab had a data loss incident a couple of years ago, and the whole thing was live streamed. Them troubleshooting. I remember my kids asking me, "Dad, what are you watching?" And I was like, "Daddy's watching engineers troubleshoot."
Engineers sweating. Yes, I remember this one. We were putting transparency to a different level. That's also the case for security, but obviously we are not sharing everything that we are doing. There are some discussions recently, for example, about the roadmap and what we are planning to do in the next 6 months. But basically, everything otherwise is completely public. The software that we're using, the roadmap of the product is completely public. Our process are completely public. You have the handbook of GitLab, which is the manual for every single process for every single employee in GitLab. It's something like 10,000 pages now. It's completely public, and you can contribute to that. So doing security in this kind of environment that's a challenge. With transparency comes a lot of challenges. Also, the fact that we're completely remote, we don't have any physical network, so that means we are embracing everything that is close to zero trust. We can't trust any of the device, any of the user, any of the entity that is connecting to our network. And that's also a challenge, because we never know where the data is going to come from. And that's also a lot of processes that we have to put in place.
Philippe, one of the interesting issues that comes around when we talk about trusting third-party software really comes down to that trust. That I don't know, when I write an import statement in Python, when I run an apt-get command, or apt install, I should say, I'm trusting where that software comes from. I don't know what's going on behind the scenes of that project. Like, has someone left? Has an evil person taken over? Have Russians dropped off like 2 duffel bags, maybe 3 duffel bags of money on a person's doorstep and said, "Hey, build in a back door," right? I don't know that when I run that command. How do you recommend that we validate some of those components on that level?
That's probably the hardest thing with dependencies, I would say, because as I said, you can never trust anything, even though the dependency that you're using is coming from very trusted source. There's always a chance that one of the maintainers has been compromised, or one of the source has been compromised, or anything in the chain, even the registry that you are using to download the dependency could be compromised.
Right.
So we are working heavily on that. There's a project called Dependency Boat at GitLab that is specifically designed to work with these kind of cases. As I said, there's no magical recipe when it comes to dependencies. There is no way to have something completely safe where you can say, okay, it's good to go and I'm 100% sure nothing bad will happen. So this dependency boat that we're working on, it's going to be a tool, and it's already a tool. I think we're already at the second iteration of this boat. It's a tool to understand the changes that you are going to introduce if you install or update a dependency in one of our projects. So we make sure that everything that is going to change is reviewed. And when I refer to the size of the company, it's extremely hard for a small company to achieve a lot of maturity in this domain. That's one of the things that we're using to measure how good we are doing with dependencies. We have this maturity model that we just introduced at GitLab. And we know that we need to get better on some points. We have a roadmap and we know where we are going to mature. And being able to manage better dependencies is one of our priorities. For example, we want to target a point where dependencies are only installed from the GitLab network. That means we're going to whitelist all the dependencies one by one. We're going to review all the code changes in there. We're going to make sure at some point that everything that goes through the installation process has been reviewed by a security engineer at some point. That's extremely tedious. It requires a lot of automation, a lot of people, a lot of time. We're not there yet. We know that we want to get there. If you start a new project today, a new startup, and you want to get there, it's going to take years to get to this maturity. So don't try to get everything done by the first year. It's never going to happen. You have to be very efficient, very conscientious,
conscientious, I think, is the word
of our maturity.
Yeah. No worries. I was struggling with I couldn't remember what SCA stood for, so don't feel bad. Hold on. Lee had a question.
So I was thinking about, and you kind of touched on it, how do you figure out what's good enough? And it sounds like you're providing the tools so that at least I could, if not sleep deeply, I could at least rest comfortably at night, not worrying about if I leverage the services you're providing. I'm not trying to say it's silver bullet, but it sounds like you're helping me move the bar over. And is this also helping you guys sleep better at night?
I mean, this dependency boat that we're deploying, it's something to help the developers understanding again the impact of changing something in the dependencies that we're using. So that's a good step forward. It's not perfect, obviously, because that's not going to tell you if something is really malicious in a dependency, but at least we are going to highlight. And that's going to be a kind of Rails guide for the developers to make sure they understand if the package is still maintained, who is maintaining the package, if it was updated recently, if it's used around the world. If you're using something from Uber, for example, it's not the same weight as something that is developed by a few developers that you absolutely don't know, and from a dependency that is used by 10 people around the world. You're going to put a lot more trust in something that is developed by a well-known company. But again, you can never trust that completely.
Right. Yeah, but you're helping automate that process, right? Sorry, Adrian, just had a comment on this, because I'll do that manually, right? I'm like, I need a library or module for XYZ. And you 3 or 4 different options out there, like, and you have your criteria. I want something that's popular. I want something that has code commits at least within the past maybe 6 months or a year, right? And you kind of like run through your own little list. It sounds like you can help automate some of that.
Let's be real, Paul. Like way up there is, does it work?
Does it work? Yeah. Is it compatible with my code, and does it work? Right. Those are the first 2 questions.
The previous 3 you tried didn't work.
Yeah.
So when the 4th one works, you don't care who's
so I'm going with
maintaining
meet my deadline. Got to meet my deadline. Yeah. Sorry, Adrian, you had a question.
Yeah, so kind of, on that point again, let's say I manage a really popular library or tool or something like that, open source repo, and somebody gives me a giant bag of cash to take over control of it. Yeah, I mean, there's little to no requirement, nothing to enforce me to let people know that. I mean, maybe at most you see, some new code changes. You see maybe some of the maintainers change. You can monitor that. But kind of my question is, like with Package Hunter, reading up on it, I couldn't really get a sense of how it works. Is it comparing against a known list of bad applications, or is there something dynamic where it's actually looking for certain known malicious things within the applications themselves in real time as you run it?
So it's kind of both. We have a predefined set of rules that are shipping with Package Hunter for some packages. We also have a set of rules to just be able to identify something malicious. That, for example, we know that any access to this kind of website based on the IP or the network of the website, if you have any access on that, that's instantly suspicious. It's a red flag. Everything other than that, we don't know yet. That's the gray area. That's where you need to investigate. And that's what we do. Package Hunter is running in the pipeline. So when we install the dependencies, when we package GitLab, for example, it's running in the pipeline, and we generate an artifact from that. This artifact is going to report to something that we call dependency scanning. It's a feature completely integrated into GitLab. And that means in the pipeline, directly in the pipeline view, we are going to have a security tab listing all the vulnerabilities that have been found in the process of the pipeline. And Package Hunter will just report as any other analyzer in this matter. So it's going to report you have a connection to this distant IP. Do you trust that or not? It's your responsibility to tell Package Hunter, I trust that or I don't trust that. If you dismiss the finding, obviously you won't see that again. But if you create an issue for that and you investigate and you find something, that's a win. You discovered something that you would not be able to discover if you were not using Package Hunter in the first place.
Right.
I found that if you've written any kind of software, it usually has bugs and or typically doesn't compile or typically doesn't run the first time, right? I mean, that's anyone that's written any kind of software, we kind of run into this assumption like there's going to be bugs. And as developers, I mean, most of us are conscientious about that and want to fix them. And I think that's the reason why we kind of get annoyed as developers when it's a false positive, when someone tells us we either have a vulnerability or a bug that really isn't a vulnerability or a bug. And when I have looked in the past at systems that identify, hey, I'm running a vulnerable library or module in my software package, that when I look at that sometimes, I'm like, yeah, but the vulnerability's in function XYZ, and I'm only calling function ABC and maybe a couple of other methods or functions in that library. I never call the vulnerable function. From an automation and software perspective, that's a difficult thing to determine. Philippe, do you have ways to kind of deal with that or working on that particular problem? Because it's not an easy one either.
Yeah, that's a very tough topic. Something very, very technical, being able to trace exactly what you're using in a dependency.
Yeah.
The problem is, when we discover something, there's an advisory that is generated with a CVE. So the information is spreading really fast. I mean, as soon as there's a CV, it's going to be included in our dependency scanning feature, for example. And since dependency scanning is running everywhere, as soon as there is something somewhere, it's going to trigger a notification for us saying you have a dependency to update. In this case, we investigate and we decide if we're affected or not. If we're affected, obviously, we are going to create a patch or we're going to update the dependency to the right version. Now, the problem is you could investigate and find nothing, like you're not using this XYZ function that is vulnerable. Is it still a good idea to use this dependency and this exact version that you know could be problematic in the future? How do you know that in the future someone in your team is not going to use this XYZ function? So it's always safer for us to just update the dependency or make sure that we're never going to fall into this trap. Also, because we are in very highly regulated environments, we have requirements from various government agencies when it comes to dependencies and vulnerabilities. As soon as we detect something, we need to make sure, we need to ensure that it's never going to be a problem. So we need to update the dependency, even though we're not affected by the problem.
I agree with that approach, Philippe, because I think that if you're in a continual process of keeping all of your dependencies up to date, that when a really big bug comes out, perhaps, and you've got to go fast, you don't have to go from version 1 to version 3, right? You go from version 3.0 to 3.1 of that dependency, and it's much easier. And you're kind of chipping away, doing smaller DevOps style, smaller releases, right? Breaking up the work into smaller chunks. I agree with that philosophy. Because then you get into weird things like, oh, I do use that vulnerable function, but I don't use the parameter that triggered the vulnerability, right? That's even harder to discover. So I like the idea of just patch it, right? Just upgrade it.
It's always a good idea, as you said, just for the sake of the technical depth that you're going to accumulate on these projects. You don't want that. But as I said, there is no magic recipe between I want to keep everything safe. I know that at some point...
Oh, Philippe's getting audio from something else. It sounds like music.
Oh, I hate that. Yeah, those headphones connect to multiple devices, and if you get a phone call, it pulls you away.
Yes.
Oh,
Excuse me, I'll be back in a second.
Sure.
Yeah, that's happened to me.
My Bose used to do that.
It's an amazing feature.
It is.
Until you realize sometimes you don't want that to happen.
Yeah, it's not a smart feature necessarily. It doesn't know you're recording a podcast.
Yeah, no.
Sorry. Could you hear that? Could you hear the music?
Just a little bit. No, it's fine. You're fine.
I don't know. There was an Amber alert, and kind of my Bluetooth headset decided that it would be a good idea to start music somehow, but that's crazy.
Yeah, we were just talking about it. That's happened to both of us.
Absolutely. So. Philippe, anything else you want to share with our audience about GitLab? Any other releases or tools you wanted to mention?
There's one project that I'm working on currently that is called the GitLab Inventory Builder. As I said, we have thousands of projects at GitLab, and it's really hard for us to figure out exactly what are the components that we're using. And so to be able to cherry pick projects in different namespaces, I created this inventory builder so that we can get this kind of bird eye view of all the dependencies, all the components that are involved at some point in the production of GitLab. So that's something also that we can share. It's useful for us for many reasons, because it's very easy to use. It's generating a database that you can query when it's running. And so that's a great way to spot dependencies, for example, that we're looking for very easily.
Yeah, the namespace is one we didn't really touch on either, right? Where you have a namespace collision or something's named very closely to a library you're importing, right?
Well, it's more like GitLab. We think, but the way we are creating our features is a kind of top-down layout where you have the instance, you have the group, and you have the project. And when we start a feature, we always start at the project level, and then we move that at the group level, and then we move that at the instance level. It's working great on the paper. It's not working great for us because we have, for example, the gitlab.com/gitlab-org namespace where we have everything related to the product. But in there, we have a lot of projects that are designed for demos or for just testing or just for anything that is not related to the product. And it's still in the GitLab org namespace. So if you have a dashboard at the group level, it's not working great for us. So that's why we need to be able to cherry pick the projects, the exact projects that we want to monitor and keep an eye on. So we do that and we download all the vulnerabilities and we manage the vulnerabilities that way with this inventory so that we can keep track of the metrics over time.
Fantastic. Philippe, thank you so much for appearing on Enterprise Security Weekly.
Thank you for having me. That was a pleasure.
Make sure you visit securityweekly.com/GitLab to learn more. Stay tuned. John Smith from Extra Hop coming up next.